All right. All right, raise your hand if you have questions, please. Abby? Number 6. All right, somebody help me out on number 6. What'd you do first to number 6? Abby?
I don't remember what I did, but on my paper I have the interval of x minus 3 minus 5 over x dx.
All right, I agree.
And then I have 1/2 x squared minus 3x plus, and then I didn't know what to do with the 5. I just didn't know. And that was my only question.
Okay, what do we do with 5?
Take it out?
And just take it out. It just goes in front. There it is.
That was all.
So wait, your U, what was your U?
There was no U.
Why? Oh, why?
Because there was nothing inside of something else.
So you only at the bottom? I don't know how you. What?
All right. Anytime you have, we talked about this a few times. Anytime I have a polynomial on top of a monomial, what are we supposed to do?
Separate it.
You're supposed to separate. So we did x squared over x, which gave me the x. We did 3x over 3 over x, which gave me the 3, and then we did 5 over x, which gave me the 5 over x. And then I integrated each one of these by itself. Integrate this, I get this. Integrate this, I get this. This right here is the same thing as 5 times 1 over x. So the 5 comes out front. Integrate 1 over x, gives me the natural log of x.
So wait, you said why not all those ones did you do natural log?
I did natural log.
No, I'm not. So why did you have U on that? So you said it was
Because there's nothing inside of something else.
So when you say that, what do you mean there's nothing inside of the else?
Well, I've got x squared plus 1 inside of the cube root. I've got 5 minus x cubed in the denominator.
But you said we couldn't do the cube because when you do it, it's 1/3 times the power of 1.
Correct, but I still use a u on it. It's just not going to be a natural log.
So
Tara,
Yeah.
you go downstairs. There should be 2 sets. I'm sure it's by the printer. I'm sure they pulled it out for me.
Okay.
It has something to do with E on it.
So then,
2 different sets.
so let's say number 7, x squared minus 5x minus 1 and 2x minus 5. You don't use U for that?
You do use U for that. What's the difference? Can somebody explain to him what's the difference between this one and that one? Because it's real simple. Monomial in the denominator. When you have a monomial in the denominator, it's not going to happen. So you got a polynomial in the denominator, that's when I need
So
a
you're
U.
saying you always look at the denominator?
If it's a rational function, meaning a fraction, I want it to be the denominator.
Okay.
But if it's a polynomial on top of a monomial, we need to split that up into separate things. Zach?
Number 9.
Number 9. All right, number 9. What does U need to be on number 9? Natural log. Because on the video, what did I say?
That we don't know how to integrate.
You don't know how to integrate natural log, so anytime you see it, it's always going to be your U. So the derivative of a natural log is 1 over x dx. So 1 over x is taken care of by this x that's on the bottom. So that means I'm just dealing with u to the 5th du.
So your top doesn't have to match. It doesn't.
It might help. It might help if you understand that this right here. That can be rewritten as this. So when I do u of natural log of x, and then the derivative of this, that means the 1 over x and the dx turns into du. And the only thing left is the outside function, which is 5, with the u inside of it. So that gives me 1/6 u to the 6th plus c, 1/6 natural log of x to the 6th power plus c, not 6.
Would we need to put the x in the absolute value?
Good question. I'm glad you asked that. Everybody hear Hunter's question?
Yeah.
He wanted to know, do we need to put the x in the absolute value? The answer is
Not no.
no. And why is it no?
This is not wrong, but because like they cancel out after long absolute cancel.
No, Brady?
Was it was your new thing?
It already existed. That's why. If it already exists, then however it is, that's how it's going to be the rest of the way. If you put the natural log into the problem, that's when I need absolute value.
Like,
All right, let me see if somebody else has one before I give Zach another one. Anybody else have a question? And somebody else before I give you another one. Anybody else have a question besides? All right, what do you got, lady?
Can you do 13?
13.
So close to leaving.
All right, 13, u needs to be
1 plus natural log.
1 plus the natural log of x. So that means I end up with 1 over x dx. Okay, and remember, I can rewrite this as 1 over x, 1 plus the natural log of x cubed dx. Thank you. So, the 1 over x and the dx are taken care of. So that means I just have u cubed du, and I need to change my limits. Is that 1 an e? Is that an e?
Yes.
Okay. So if I plug 1 in here, we all know the natural log of 1 is 0. So 1 plus 0 gives me 1. And then e, natural log of e is 1, and 1 plus 1 gives me 2. So 1/4, 2 to the 4th is 16, minus 1 to the 4th is 1. We end up with 15 over 4. Raise your hand if you can tell me what 15 over 4 represents. Everybody in there should have their hand up. Jennifer?
Area under the curve
And?
and the change in the function of
Perfect, thank you. All right, anybody else have a question that has not asked one yet? Brady? All right, Zach, what do you
I
got?
want to make sure I got this question right. The number 12, 1/3 natural log, absolute 4 minus 3 cosine theta plus c. Oh, okay.
1/3 natural log, absolute value of sine plus c, or absolute value of 4 minus 3 cosine theta plus c.
Yeah.
foreign language, maybe.
Did you not watch my video?
No, I did, but what, you just said it all so fast. Just, I gotta see it. Like when you're like saying it, like it sounds.
That's the answer. Is that what you got, Brady?
I figured it out.
If you'd have done it, is that what you got?
Yeah. Number 9, when it's 1/6 times natural log x to the 6, can you cancel out the 6?
Oh, I forgot about that.
Just a second. So number 9.
Well, because it answers
All right, what did I give?
1/6 times the natural log of x to the 6. Can you cancel out the 6?
1/6 natural log of.
In parentheses. Like the whole, yeah, the whole the natural log is in parentheses. Can you cancel out this?
Can I cancel this and this?
Yeah.
No. If it was like this, yes. Because the 1/6 only goes to what's here. It doesn't go to there.
Okay.
Good question. Anything else? Abby?
Good.
What's she saying?
10.
Oh, never mind.
Oh, never mind.
Yeah, I got it.
What was the answer?
10 is going to be 5 natural log of the natural log, or 5 natural log absolute value natural log of x plus c.
Will be x natural
Oh,
log
so
of
you
x.
can plug that in.
Why not?
No. Because the x goes away with your du.
That was my
But I thought you re-plug in what your u was.
So if I were to rewrite this, that's how I do it. So there's your u, there's the derivative of it. So I just have 5 natural log absolute value natural log of x. Plus
So why didn't you separate the x and natural log of x? Both on the bottom.
because I knew that the derivative of the natural log of x is going to give me 1 over x.
Well, I get that's the derivative. Well, actually no. I thought your u is x natural log of x.
No, it's just natural log of x. It's just the natural log of x.
So how does the x appear in the front?
Because when I do u natural log of x, the du is 1 over x dx. So that 1 over x takes care of that.
Yeah, I got that that's the derivative. But
Alright.
the u comes before the derivative, so how can you just get rid of the x?
U comes before the derivative.
No.
How can you just get rid of the x?
This x,
Yes.
I just told you. This right here turns into this. So this and this turn into du. They are equal, so I take one out and I put the other one in its place. That's what it looks like.
Yeah, that's why I got it. But whenever I thought, the reason I thought, cause I just have an extra x, but I thought the u was supposed to equal x, whatever your bottom number is. Or,
Remember, whenever you got that natural log is going to be your u.
so if you say if it was 5 natural log of x, you don't include the 5.
I would only do it like that other problem where stuff was being added together. Right here, and it's inside of parentheses, then all of it's going to be together because it's inside of something else. If this was natural log of x plus something else, then they would have to go together. But since it's multiplying, and I know the derivative of the natural log of x is going to take care of that x, then I'm not going to do it.
Okay.
That's another thing you need to keep in mind when you're doing u's, is you need to understand that the derivative of your u, you want to exist. So that's why we know we only want natural log of x to be our u, because we know the derivative of it is going to take care of that x. So you got to keep that in mind.
Let me try that straight. You pulled the 5 out in front,
Pulled the 5 out in front.
and then since you knew that your derivative of log natural log of x is 1 over x, you knew that that would simplify the bottom, because you know it. When you move the 5, it becomes 1 over x natural log of x. So you knew that the 1 over x would take care of the x outside the natural log, right? Okay, I got it.
All right, let's move on to the day.
Wait, what was our 14 answer? I got 20.
After we get done, I'll look it up and let you know.
All day.
Is it just one? No. Where are we going to be? Because I'll be late for my class.
Good enough. All right, here we go. So we're looking at integrals of expressions involving exponential functions. So again, before we learn to integrate this, what do we need to remember? We need to remember the derivative. So
Isn't anything that e like 1 like that?
you can tell me what the derivative of e to the x is, Abby?
It's e to the
It's
x.
the derivative of the exponent.
Isn't just e to the x?
You gotta give me a little bit more.
E times.
Yes. So it is e to the x times whatever the derivative of the exponent is. In this case, since it's just x, it would be times 1. So that means if I integrate e to the x, if I integrate both sides, what am I going to get? I'm going to get e to the x is what I'm going to get. Okay, so if I integrate e to the x, I get e to the x. Question?
So I'm guessing we'll get to where it's like e to the 2x.
And then you just use a u.
Okay.
So if it doesn't have, if it's just an all variable in front, it's just, you don't use the u.
So if it's just x in the exponent, I don't need a u.
So is there any time where you're going to have to separate it out?
Separate it out. What do you mean by
Like that one
separate?
column, back is a polynomial and a monomial.
If I have a polynomial on top of a monomial, I'm going to separate it out.
What if it was e to the x to the x?
It's not going to happen.
Okay.
All right. This one might take a little bit more. Can somebody raise your hand? Tell me how to take the derivative of something like a to the x. It would be like 2 to the x or 3 to the x. Remember how to take the derivative of that?
Oh,
Brady?
Say nose goes.
Nose goes.
you said it's the same thing in derivative as 2 to the x?
2 to the x. Anybody remember how to take the derivative of 2 to the x or 3 to the x or 4 to the x? On and on and on.
X plus 1
Oh, you
over.
look back there. Look back there.
John Ryan?
Is it
I'll take the
similar to
derivative.
general? Like you bring down your exponent
No.
and then keep the inside?
No.
Leilani? Do you know? Don't look this way.
X times
All right.
a
It is
x plus 1.
the natural log of the base
Oh, you got me there.
times itself. And technically, that's what I'm doing with e to the x.
Okay.
But when I do natural log of the base, when I'm doing e to the x, that's the natural log of e. And what's the natural log of e equal to? 1. So therefore, I don't have to show it because it just turns into 1. Okay? So, derivative of a to the x, which is something like 2 to the x or 3 to the x, is the natural log of the base and then times itself. That's how you take the derivative. All right? So that means I need to integrate it. Hey, Maddie. Come on, Brady. For me.
Oh.
All right, so I want to integrate a to the x, and over here I have a natural log of a times a to the x. But I just want to integrate a to the x. So somebody help me out. Well, let's say it again.
You put it out front.
All right, I can put it out front. And why am I allowed to do that? What does this represent? That's a coefficient. Very good, Abby.
Yeah.
Okay.
Yeah.
Now, what is this left side going to be? What's the integral of the derivative? It just cancels, so this is a to the x. So I'm interested in what that right there equals. So what's one more thing I got to do to figure out what this equals?
Divided.
Divide it. There it is. So, what's the difference between integrating a to the x and taking the derivative of a to the x?
Dividing.
The natural log is.
When you're integrating, you're dividing by the natural log of the base. When you're taking the derivative, you are multiplying by the natural log of the base. That's the only difference. Got it? Good. All right. So let's give it a try.
Easy.
All right. On number 1, do I need a u?
Yeah.
Yes, I need a u. What's it going to be?
Apply that.
5x. So that means I have du equals 5 dx. So that means I need a what? A 1/5. And then I have e to the u du. And if we integrate e to the u du, we get e to the u. Don't forget your plus c, and then plug back in for u. There it is.
So wait, when you use your du though, you just have dx. So how does it cancel out the 5x or e?
Say that again.
How do, like, other ones you have to get like you have to like cancel out more than just dx.
All right, so u equals 5 to the x. So I took the 5 to the x out. I put u in its place. Du equals 5 dx. We moved the 5 over. That's where the 1/5 came from. Du is equal to dx. I took the dx out. I put the du in its place. It's just substituting. Yes.
Can you like just look at this and like say
I was hoping you were saying. you were gonna say
divide
that.
by the derivative?
All right. So if it's a basic e to the 5x or e to the 7x or e to the 11x, all I have to do is 1 over whatever my coefficient is, and then e to whatever is there.
Wow.
So you can, as Mallory is saying, the better you get at this, you can go straight there. But make sure you're
But
comfortable
can
with
you
it
do
before
that
you
with number 2?
Yes, if you're good.
So you can
So
just look at
we're
your
gonna see if you can come up with it. All right, what do you got?
Is he like pi?
E is similar to pi, yes. Well, how is pi and e similar? Can somebody tell me how pi and e are similar? Ivan? They're both constants. Yeah, I need a little bit more. They're what? Irrational or irrational? They are irrational numbers.
What's the number?
That's what I meant.
Pi or e is 2.7 something something something.
You don't have it. That's what he is.
E is equal to 2.714 and something else.
I don't even have
E is an actual number, just like pi is an actual number.
I think I got number 2.
All right. What do you got?
-4t, the 1 minus x plus c.
There you go. Did you do it in your head? Did you write it down?
Well, I mean, I kind of did. I didn't write t like the u, so I got, but I just like went and like divided and.
All right, so Mallory did number 2 in her head. Tell us how you did number 2 in your head, Mallory.
Well, I knew 4 was gonna have to be out.
4 is going to have to be out there.
And then divide by the derivative of 1 minus x, which is -1.
So I need a -1.
That'd be -4.
And then I just gotta have
the same in there. So.
E to the inside. Very good. If you can't do that, do the u. You'll get the same
So
answer.
say the last one.
Always better safe than sorry.
So they last one 5e to the 5x. Would it just
5e to the 5x.
Would it just been e to the 5x plus c? Okay.
I like my nails. So then on 3,
On 3,
then you just get e to the x squared. No.
3 you get e to the x squared. Well, let's see.
Oh, plus c.
Okay, why is that, LED?
Well, you took out the 2, and then divided by the 2, so that cancels. And then you just plug it back in. Right?
Go.
Wait, what happens to the x?
Well, what's the derivative of x squared?
2x.
2x. There it is. So it's a perfect match. So then all I need is the e.
Wait.
So whenever your derivative is a perfect match, it's always just going to be whatever your e
So
is.
can you do it in your head on
Why
4, or
did
do
it
you
go
have to
away?
Well,
work
okay,
stuff
I'm
out?
I would work on 4. Abby?
Why did they go away? Can you show me?
Yeah.
U equals
U equals x squared, du equals 2x dx. So the 2x and dx turn into du, and then I have e to the u.
Oh, okay.
me.
I know. When I have 4 and U together, it always looks like this.
I usually draw those pointing fours. If you start drawing pointy fours, that'd be fantastic.
Yeah, triangle line down.
I'm not going to draw my whose 4s are the? Is it your 4 that looks like a 9?
No, my 9s.
Or your 9s look like a 4?
But
That's
no,
what-
it's because I write my 4s like the normal way, like the open, like.
Draw your 9. We can't see that.
We are not there.
Here, pass it.
Oh yeah.
Don't look at my work, by the way.
Don't look at my work.
All right, Maddie, number 9. What did you need to be on number 9? Or sorry, number 4. All right, Maddie. 1 over x. Okay, what's the derivative? Somebody, what's the derivative of 1 over x?
Natural log.
No. If I integrate it, I get the natural log. I'm not integrating. I'm taking the derivative.
X to the 1/2.
Nope.
Negative
Ethan?
x.
Thinking about it.
Can you not post that on the YouTube video?
It'd be negative half to the negative 1/2 instead of then x over.
It's negative 1 over x squared.
Just make it negative and let's just add 1 to the denominator.
All right, so it would be, this is x to the negative 1. So I subtract 1, which gives me
X to the negative 2.
negative 2. I forgot to multiply first. So we end up with negative 1 over x squared. So that's the problem once you get into the integration, is sometimes we forget how to take the derivative. So don't do that.
Yeah.
Make sure you keep it straight. All right, so
Why is the u 1? Why is not 2 over x 2 or 2x squared? Why is u not 3x squared?
all right, good question. This is a good point, a good opportunity for me to tell you something. Anytime there's only one e, your u is always going to be the exponent of the e. Anytime there's only one e, your u is always going to be the exponent of the e.
You take the bigger power.
There's one e right there.
Yeah, but what about when
And we'll get there.
Today?
Today. All right. So what do I have that matches?
Not the 2.
The x squared does. So what needs to go out front?
2. 1/2. So 1/2.
The 1/2 and the negative needs to go out front. Then we're integrating e to the u du. So we end up with 1/2. I'm going to go ahead and substitute at this point to save myself a step.
Would the negative 1 just go to the outside since it's 2x squared on the bottom?
Yeah. So I move the 2 out. I move the negative out.
What did 2 go?
Did you have done that one in your head?
Yes.
What did 2 go?
I wouldn't recommend you guys
He's
do
a
it.
wizard.
What?
What did 2 go from?
No.
He's a cowboy today.
2 in it.
I know. That's why that 2 had to come out.
He can't do this next week.
Okay.
Guys, Tara didn't know what yee meant. I know, every time I say Tara's over to our class. I always say like those yee and people are like, what's a yee? And I'm like, I tell her. I've had to explain what a yee is to people.
All right, number 5, Advait. What's my u on number 5?
Sin x.
Sine of x. Derivative of sine is cosine of x dx. So some of us, after they've done that, may be able to go straight to the answer. Are you guys that good, or do we need to do it?
I
But why is it going so fast?
It's just
Oh, sorry, I had a brain fart.
E to the sin x plus c.
Because the cosines
Everybody with me?
It seems so easy, but
It is.
Wait, why?
okay. Don't go on that.
Did you cancel them out? Cancel cosine x dx. That's why it's equal to that.
Yeah, the cosine x dx turned into du.
So why?
The sine of x turned into u.
Wait. So like,
Quiet. Too much talking. Mallory.
something about doing this in my head. Oh, never mind. Never mind. I figured it out. I did something wrong in my head because I was trying to do that.
Abby? You good? Yeah. All right, number 6. So what's new about number 6? I have 2 e's. Whenever you have 2 e's and it's a rational function, your u is always going to be the denominator.
Okay.
What about irrational?
There's no such thing as an irrational function.
I was testing.
All right, so du is going to be negative e to the x dx. So what does my new integral look like?
Negative.
Negative. And then what's on the inside?
1 over
One
u
over
du.
1 over
One over
u
du.
du. Perfect.
Well,
And the integral of 1 over u du is
Natural log.
natural logs. Absolute value of u plus c.
So if you have more than one e, your answer probably some natural log is the answer.
More than likely.
I prefer, like more than likely 100% of the time.
Well, there's no such thing as 100% of the time.
If there's such thing as there not being a rational
I'm right.
problem. 100% chance that's not gonna happen.
You're 7.
So
It's a lot easier. Wow. If I put a Y right here, and here, it says
All right, Roshan, what's my u on number 7? Shh. Quiet.
e to the x plus e, or the negative x.
E to the x plus e to the negative x. And why did you choose that for your u?
Because when you have more than one e, it's always the denominator.
Very good, thank you. So I've got a bunch of e's. Whenever I've got a bunch of e's, my u is always the denominator. So derivative of e to the x is e to the x. Derivative of that is going to be negative e to the negative x dx.
wait, I thought you multiplied by the derivative was at the top.
I did.
So you should multiply by negative and it should be plus.
It started out as plus.
Oh, it did. Drop it down.
All right, so what's my new integral look like?
1 over u to the times du.
1 over u du. So we're looking at the natural log of u, which is e to the x plus e to the negative x plus c.
Did you have done this one in your head?
Yes.
Okay, have you
You're
do
a
this one in your
calculus
head?
teacher,
Like,
you
have
can do all
you
that.
Well, if you have u and the derivative of it is an exact match, it's usually pretty easy. When it's not an exact match, that's when you don't want to do it in your head. So in this one, I knew my u had to be at the bottom. I knew the derivative of the bottom was an exact match for the top. So it was a 1 over u. So I knew it had to be a natural log of the denominator.
So if it's an exact match, can we just stick that into the natural log?
What your u is? Yes.
That works.
If it's a situation where u came from the bottom,
And
yes.
it'll be absolute value.
All right, number 8. Somebody raise your hand and talk to me about number 8. What we need to do on number 8, John Ryan.
Could you break it up?
Okay. What tells me to break it up, John Ryan?
Because you have a monomial.
All right. So e to the 4x over e to the x turns into
E to the 3x.
e to the 3x. Good.
Okay, good. We did that right.
All right. 2e to the x over e to the x. 2. And then 1 over e to the x. 1 over e to the x, which is also
E to the negative x.
e to the negative x. Very good. And all 3 of those we should be able to do in our head.
Okay.
Elias, if I integrate e to the 3x, I get Haley? Zach?
What?
If I integrate e to the 3x, what do I get?
3 e to the 3.
Close.
Okay.
Jarrell?
It's not 3 to the 3x.
No.
Uh,
If I was taking the derivative, it would be.
Oh,
Oh.
Mallory?
130.
There we go. 1/3 e to the 3x. Integrate 2 and I get 2x. And the last one, Courtney, if I integrate e to the negative x, I get
Negative e to the negative.
perfect. Very nice. Very nice.
so was it e to the negative x because you had to bring it down from the bottom?
Yeah, because it was 1 over e to the x, which is the same thing as e to the negative x. All right, last 2.
That's why.
Yes.
Speaking of argument contest, you don't have homework today.
No. Natalie, number 9, what's my u?
6.
There you go. 4 minus x squared. Because when I see stuff like this, I need to think about that 6 being the same thing as E. So I would say if this was E, what would my U be? And I've always told you if there's one E, your U is going to be the exponent. Ethan.
Did you make that 4 minus x to the cube? 4 minus x is on the...
Nope. Nope. That would have to be a natural log. I don't have a natural log, so I can't do any moving. All right, so derivative of this. Brady, what? Yeah, you did. Come on.
I said yeah.
Hunter?
Is it negative 2 times 4 minus x cubed?
Negative 2 times 4 minus x.
Not cubed.
Not cubed. You were trying to integrate and take the derivative at the same time. We're taking the derivative.
Why is it negative?
Yes, I was.
Hunter, why is it negative?
Because you take the derivative of the inside, and that's negative 1.
Yeah, so the derivative of the inside is going to be a negative 1. So that's where the negative came from. What'd you say? No, remember this is chain rule problem. So the 2's got to come down. The inside stays the same. New exponent is 1. Derivative of the inside.
Yeah.
Oh, now can I distribute the 2? I can, but I don't want to because I want to match. So, the 4 minus x is taken care of, but I have this negative 2 left over, so what needs to go in front of my integral? Negative 1/2. And we have 6u du. All right, so I need somebody to remember, it's been a while since the start of this class, how to integrate 6 to the u. Raise your hand, please. Alidi?
1 over the natural log of 6 times 6 to the u.
Perfect.
Wow.
Very nice.
You, right?
Gosh, that just grinds my gears.
So, plug in my u. There it is. Now, what else might you see right here instead of 2 natural log of 6? Natural log of 36. I might see the natural log of 36 right there instead of 2 natural log of 6. Because, yeah, remember, if you got something in front of a log, you can move that number to the exponent, so that would be 6 squared. So you might see on a multiple choice, you know, this right here end up being natural log of 6 instead of 2 natural log of 6.
My brain's ready at that problem.
So make sure you're aware of that. All right, last one.
Let's see.
Now, back to last year, one of the things I hope I ingrained in you, hopefully somebody in here remembers,
Oh my god.
is what did we always say is true about the base of an exponential function or the base of a log?
It's always if they split each other, right?
They always stay the same?
It always stays the same. Thank you. Okay? The base of an exponential function and the base of a log always stay the same. Okay? Because what a lot of people are going to do is you might end up with something like 4 minus x squared times 1/2. And what do people want to do here?
Turn that 6 into a 3.
They want to turn that 6 into a 3 and make it 4 minus x squared. But I can't do that because what has to be true about the base? It stays the same. You can never change it. So do not do this. Very bad.
Big no-no.
Big no-no. All right. Number 10. Lonnie, number 10. What's my u need to be and then why?
1 minus 3 to 2x.
1 minus 3 to the 2x is correct. Why?
Because there's 2.
Because there are 2 of them. Remember, I want to treat an exponential function just like I would an e. So if this was an e, that would mean there's more than one e. And then when there's more than one e, your u is the denominator. All right. So derivative of this, the 1 goes away. Raise your hand if you can tell me the derivative of negative 3 to the 2x.
Negative 6 to 2.
Natural log 3.
Natural log of 3
3 to the 2.
times 3 to the 2x
2.
times 2. And don't forget about the negative.
Wait.
Why?
I need some explanation.
Why? I think the derivative
All right.
of e is the exponent times the base, or Whatever it's called.
It's the exponential times the derivative of the exponent of the exponential. So the exponential times the derivative of the exponent of the exponential.
I know, so why is it not negative 6 to 2x?
Where are you getting 6 from?
3 times 2.
3 times 2, this one?
No, the other.
Or this one?
Yeah.
What did we just talk about? What did I just emphasize?
What?
What did I just say about the base of an exponential function? Has to stay the same. All right, questions on this? Questions how we got the derivative? Abby? Questions? Speak up. John Ryan?
Where did the natural log come from?
Where did the natural log come from? Somebody tell me.
Because I get like keep your base and multiply by the derivative of the exponent
And it's always times the natural log of the base.
times the natural log of the base.
We just don't show it on e because it's always natural log of e, and natural log of e is equal to 1, so it never shows up. So if it's something other than 1, you've always got to have the natural log of the base. So it's the same thing as e, but then you got to throw the natural log of the base in there. Yes.
Is the negative because it's 1 minus 3?
Yeah, it's a negative because of that right there.
So let's throw this mechanical twice. So let's say it's
Quickly.
1 minus 4 to the 6x
1
minus
4 to the 6x.
So then it would be natural log of 4
It would be natural log of 4.
times 6, or 4, negative 4 to the 6.
Let's put the negative there.
Okay, it's a times 4 to the 6 times 6. Okay,
That's all there is to it.
okay.
All right, so what is my, after that, what does my new integral look like?
I don't know.
Ethan?
Is it negative 1 over 2 natural log of 3?
Negative 1 over 2 natural log of 3
of
is
the
correct.
integral 1 over u?
1 over
Good
u.
afternoon, teachers and students. Please pardon this interruption for the afternoon announcements. Just a reminder, tomorrow academic enhancement is AM. Priority subject is English, and client teachers will not be available. Also, reminder, teachers, we have a faculty meeting in the morning at 7:10. A special announcement from Mr. McIntosh, vocal music. Congratulations to the following students for advancing to state solo and ensemble. All students receive